The GIS de-icing sensitivity model provides a lot of flexibility so you can tailor your analysis to the specific concerns and priorities in your area. This video will describe some of the options and times when you might want to customize how the model takes different data into account. You can decide what data you want to include or exclude from the model. Several data sets are required. These are the USDA Natural Resource Conservation Service (NRCS) soils polygons, the U.S. Fish and Wildlife Service National Wetlands Inventory (NWI) polygons, and the National Hydrological Dataset Streams and Rivers (NHD) line file. The GIS tool provides you with help obtaining these mandatory datasets. There are other datasets that may also be important if you have specific concerns. Optional datasets include U.S. Fish and Wildlife Service, USFWS Critical Habitat Dataset, Wild and Scenic Rivers Dataset, National Land Cover Dataset, and Wellhead Protection Areas. The first dataset is USFWS Critical Habitat. If there are particular species of concern in your analysis area, this dataset may be important. The next dataset is Wild and Scenic Rivers. Some areas have significant protected waterways, and this dataset allows special consideration to be included in the analysis. The next dataset is the National Land Cover Dataset. Using the Land Cover Dataset allows you to include special consideration of specific land use types, such as agriculture. And the last optional dataset is Wellhead Protection Areas. De-icing chemicals can migrate through the soil and groundwater, contaminating wells that provide drinking water. There is no national dataset for wellheads, but if you can obtain this data from a State Department of Natural Resources, Soil and Water Conservation District, or other source, it can be incorporated into the model. Note, there is no national archive for this dataset, and availability varies by jurisdiction. Each dataset has two parameters affecting how the data is used by the model: weight and scale. The first parameter, weight, determines how much effect there is on the analysis in relation to the other datasets. This is expressed as a percentage, and the total weight of all datasets must add up to 100. The second parameter, scale, is an independent factor for each value within a dataset. For example, with the soils database, there are excessively drained, well-drained, and poorly drained areas. Since excessively drained soils facilitate chemical movement from the road into the surrounding environment, they could be given more consideration or scaled higher than other soil types when making the sensitivity analysis. Conversely, hard-packed clay soils may carry salt runoff further distances, which could impact a stream, for example. Flexibility is built into the model to adjust for localized conditions, agency priorities, and concerns. Scales are values from 1 to 9, with 9 being the greatest impact. These ranges can be changed if needed. In addition to the data-specific parameters, you can also set a buffer width. The buffer width tells the model how far from the roadway the model should consider the various datasets. Research has shown that concentrations of de-icing chemicals, typically salts, decline rapidly at distance of 10 to 15 meters from the roadway. To reduce model running times, it is recommended that a value in this range be used. Note this distance is calculated from the location of your plow route line file. In cases where effects like burned vegetation from airborne salt exposure has been observed, a buffer of 30 meters can be used. With all of the different datasets and parameters, the tool can be complex to use. A set of starting parameters is provided that will produce usable sensitivity classifications. A complete list of these can be found in the Weighting User Guide. Let's look at an example case where specific concerns can be addressed by choosing datasets and adjusting weighting parameters. Here, the area to be analyzed has drinking water wells and residents are concerned about contamination. The default parameters and required data sets will produce an output like this. Now we add a wellhead protection area data set and adjust our weightings. Here we choose the soils layer to be adjusted to 25% of the total score, wellhead data is 50%, and water data is 25%. Excessively drained soils are given the maximum scale value along with water and wellhead data. The model output will show greater sensitivity where these conditions exist. In the next example, forest and agriculture were identified as primary concerns near the roadway. For this optional analysis, the National Land Cover dataset must be added. Now, the soils dataset is weighted at 30% of the total, the land cover dataset at 40%, and water at 30%. Scale values are more important in this example, as several land cover types are represented in the National Land Cover dataset. Since our main concern is forest and agriculture near the roadway, these types are scaled at 9, the highest level. Other land types, such as developed, scrub, and barren, are given a scale of 1 since these are not a concern for decision sensitivity in this particular analysis. Using these settings, the model output is very different from the previous example. By carefully considering the concerns and priorities in your specific area, you can adapt the model to emphasize what's most important for your operations. Consulting with natural resource and land use experts will allow you to develop optimized data and analysis parameters for your de-icing sensitivity model.